Okay, so here's our second intersection of two polar curves, or polar curve system. I have two circles, 2 sine theta, which is a circle facing up along the y-axis, and a second circle facing to the right along the x-axis, 2 cosine theta. So again, just like with any systems, really you just set them equal to each other if possible and solve. So I get 2 sine theta is equal to 2 cosine theta, and divide both sides by 2. I just get sine equals cosine. And the shortcut is here is when is sine equal to cosine. That's pretty straightforward at pi quarters and 5 pi quarters. So now I take pi over 4 and plug it into either one of these two functions here. I'm going to plug it into sine for doesn't really matter. So the sine of pi quarters is 2 sine of pi over 4, which is equal to 2 radical 2 over 2, which is root 2. So one of our intersection points is going to be root 2 comma pi over 4. Second one is plug in 5 pi quarters, which is 2 sine 5 pi quarters, which is 2 times negative radical 2 over 2, which is negative radical 2. So my second intersection point is negative 2 comma radical 2 comma 5 pi over 4. But notice when I have radical 2 5 pi over 4, that puts me over into this quadrant over here. Looks like it's there. But a negative radius, as you recall, switch back 180 degrees or pi over into the other quadrant. So therefore, these two intersection points are the same, so we cross that one out. Notice though, with the curve, I have two intersection points, one at the pole and one at radical 2 pi over 4, which you've already found. So the second point here, we can really only find by a little intuition as well as by looking at the graph. Clearly there's an intersection point at the pole. A lot of times when I do these problems, if I notice that they're both equal to r, which they usually are, I just say, okay, to myself, when is this equal to 0? Because a lot of times you'll have intersection points at the pole that won't show up by algebraic means. So this has a radius of 0 at pi over 2, and this has a radius of 0 at 0. So these two curves intersect at the pole, just at different angles, different angles. So this one intersects at theta equals 0, and this one is at theta equals pi over 2. So that's why it's very important that you graph your polar curves when finding the intersections of them, because sometimes algebraically you won't find any additional points. Most times they're either at the origin or at the pole, or we'll look at one a little bit later where it's over at pi or something like that. So that's the end of that.